Did a scratcher make these marks? An experiment in tool mark analysis from the Institute for Natural Philosophy, Indigenous Mound Research Directorate. Here is the question. 3 carved figurines from the Mount Pisgah and Garden Creek corpus carry dense shading, parallel incised lines, cross-hatched lattice, fields of punctate dots. Was that shading applied with a multi-tooth implement, such as the Cherokee Kanuga scratcher, or was it cut freehand, one line at a time? The question matters because it is testable. A multi-tooth tool leaves a signature. Its teeth are fixed in a frame, so it should reproduce its own spacing wherever it touches the surface. Freehand work carries no such constraint. If the signature is present, we can say something about how these objects were made. 2 documented implements provide the reference. The Cherokee Kanuga, catalog E130488, collected by James Mooney in 1889. 7 teeth of turkey leg bone set in a quill, and a Seminole green corn dance scratcher. E397141. 6 sewing needles through a palmetto stem block. Both were measured against engraved rulers appearing in the same photograph. Calibration first. Nothing can be measured until we know how many pixels make a millimeter. The Kanuga was calibrated 2 ways, against a millimeter tick comb and independently against a 1/16 inch comb. The 2 scales agree to within 0.18%. The Seminole implement agrees to within 0.33%. Calibration is not the limiting error here. A blind check on the method. Before the catalog entries were consulted, line detection was run on both implements. It recovered exactly 7 teeth on the Kanuga and exactly 6 on the Seminole scratcher. Both counts match the catalog. The detection procedure works. Now the reference measurement, and the first surprise. The Kanuga teeth are spaced 4.15 millimeters apart. The Seminole needles, 4.32, a difference of 0.16 millimeters. Mann-Whitney P equals 0.92. Consider what that means. 2 unrelated cultures, 2 dissimilar materials, bone and steel, 2 collection events, 65 years apart, and they converge on the same tooth spacing. The most likely explanation is ergonomic. That pitch suits human skin and the human hand. This finding is unwelcome to the tool hypothesis, and we record it as such. Because if roughly 4 millimeters arises wherever people make scratching implements, then 4 millimeters is common, not diagnostic. Simulation puts a number on it. An arbitrary hand scale implement lands within 0.2 millimeters of the Kanuga 26% of the time. Within half a millimeter, 59% of the time. A spacing match is a 1 in 4 coincidence. It identifies nothing. So mean spacing will not settle this. We need a stronger test. 4 hypotheses were specified in advance, each with a named falsifier. The dots were stamped with a scratcher pressed into the surface. The lines came from a single implement per object. Dense fields were built by repeated stroking, or the implement was rigid and left parallel translates. Test 1. With the punctate dots stamped, 94 dots were measured on the quadruped slab. A stamped tool must reproduce its own irregular gap sequence in every impression. This is the classic tool mark identification test, and it is far more powerful than mean spacing. 3 results. The dots are significantly organized into rows. 15 collinear runs against a null of 6.3. That is consistent with a tool, but the runs do not repeat each other's sequence. P equals 0.92, and 58% of the gaps are wider than the widest gap on either implement. Physically impossible for a stamp. Stamping is rejected. Gray to be against. 1 run did appear to match, at 0.25 millimeters per gap. Inside the noise floor, it looks compelling, but it is the best of 15 runs compared against 2 implements with the distance already minimized over reversal and sliding offset. Simulation shows how much that matters. Named in advance, that match is a 1 in 90 event. As the best of 15, it is a 1 in 6 event, and taking the best of 15 beats the noise floor by chance alone roughly 2/3 of the time. The observation did not change, only the number of chances taken to attain it. Count the search, not the report. Test 3 exposes a deeper problem. Can the line spacing data distinguish a real effect at all? The autocorrelation test is 98% powerful against tiled strokes, but only 18% against overlapping strokes, 9% against free overlap, against a 4% false positive floor. Against the mechanism actually proposed, the test is barely better than chance. This is the distinction the whole experiment turns on. Grade C means the evidence did not decide. Grade E means the method could never have decided. A negative result from a blind instrument is not a finding. Reporting E as C converts a broken tool into a conclusion. One test remained: rigidity. However a comb is advanced, its teeth are a rigid body. Lines from one stroke hold fixed offsets along their whole length. That property survives any stroke overlap. It looked decisive. It failed, and not on the numbers. The premise is false. Direct inspection shows the seminal needles are individually bent, fanning in different directions. The Kanuga splinters splay too, from 3% near the tips to 11% across the frame. The implements measure 3.1 to 21.5%. The carved objects measure 14 to 30. The reference range brackets the objects entirely. And here is the trap. To paired as groups, the objects are significantly more variable. P equals 0.032. An analyst grading on significance would call that a positive result. It is worthless. At a 15% threshold, you classify a documented seminal scratcher as not a tool. At 25%, you classify 3 of 4 objects as a tool. No threshold survives. Significance is not diagnosticity. The verdict: no proposition supporting scratcher manufacture reaches grade A or B. Stamping is rejected at grade B against. One fixed pitch implement per object is rejected at grade B against. But 2 tests are grade E. Demonstrably incapable. A flexible, resettable implement of exactly the kind documented in the Southeast is not excluded and cannot be excluded by these methods. What would settle it? Not more analysis of these photographs. We have reached the discriminating limit of 2-dimensional imagery, raking light macro photography at 20 pixels per millimeter or better. That enables the 2 decisive observables: hit elongation and orientation, which separates a pressed splinter from a rotated point, and cross-sectional depth profile. A multi-tooth implement drawn once leaves lines of equal depth, starting and stopping together. The experiment did not answer its question. It established precisely why it could not, and what instrument would. An investigation is trustworthy in proportion to the number of its own conclusions it has been willing to withdraw, and to the specificity with which it says what would have changed its mind. Institute for Natural Philosophy. Corpus compilation and standing source finds credit: Samantha Waddell.